Well, hi, and thanks for joining me here in my shop. It's June 7th today. It's been a few days since I've been in here working on this radio, and that's only because the weather has been fantastic outside. Today's another fantastic weather day. It's starting out at 10 degrees with hot sun. It's just fantastic. Okay, but I am in my shop today, so what am I going to do with this radio? Now, I changed out one capacitor. This was the blocking capacitor for the grid of the output tube. You can see it looks good at a glance. The wax is cracked here. That would allow some moisture in. I found this to be a little leaky. This is a critical capacitor. You can't afford to have any leak through a blocking capacitor, or the leak's going to affect the grid that it's trying to protect. So now the radio largely works as it is with all these other older capacitors. The replacement is down here for the one I just showed you. I also cut the lead to this big capacitor back here. This capacitor connects the B- of the radio to the chassis. Very, very critical capacitor. And what I discovered when I did that is it has a bigger effect on the radio than I expected. And with this capacitor completely out of the circuit, the radio largely doesn't work. The local oscillator shifts a little bit, and I think the antenna becomes very inefficient, so it just stops really providing a strong signal to the front of the radio, and the result is you can't pick anything up. I was very surprised by that. So I have an option here. I have a couple options here. So one is, well, just reconnect this capacitor back and leave the radio just as it is and put it all back in the cabinet and go, hey, that's good enough for a little radio like this. Why spend all the time and effort changing all these capacitors for no performance improvement? So I did change the one because I suspected I would get a performance improvement, and I did. The grid potential on the output tube went from -4 to -6 or something like that. It was a significant improvement, and almost certainly because this guy was leaking. So that was good. Now, are there more in here that are in such a condition that I really should change them? Maybe one or two of them that are in here. Well, that's a good question. Offhand, I couldn't tell you. So I have to think my way through this. Maybe look at the schematic. By the way, thank you for another schematic. Someone sent me another schematic for this radio. It's identical to the one I already had, except it's been updated slightly. The incorrect pin number has been changed on it, and a couple other things have been ever so slightly changed. And I think it's an updated version of the original schematic drawn by the original draftsperson. I think I had version 1, and I think the engineer said, you made mistakes here. Look at this, pin number's wrong. And out came version number 2 corrected. Somehow version number 1 got into circulation. You can't even tell the difference at a glance, can you? And so studied that very, very thoroughly to make sure there weren't any other significant differences between the two schematics, and there actually isn't. Okay, but thank you very much for sending it to me. Now, maybe for the duration of testing this, or for the next few things I do, I'll just temporarily reconnect this capacitor. And what am I going to do? What am I going to do? So, I was able to, or I'm aware of the problem with the blocking capacitor for a grid, and I went after that right away. I don't think there's any other such blocking capacitors in this radio. The tubes are connected together through transformers. So, but there's lots of capacitors with jobs to do. There they all are. I just don't think there's any blocking ones. So why don't we jump on the schematic, see if we can't sort of pick off which capacitor might be, or which ones might be problematic, and then see if we can go after those particular capacitors and see what happens. Sometimes when I do this on a radio, I just end up in the end changing them all, and that could very well be where this ends up too. So let's take a look at the schematic here, and we'll go from there. Okay, so this is the new version. You can tell the new version because this pin is numbered 7, which is correct. The old version, there's the old version, the same pin is numbered 5, which is incorrect, which threw me off. So that's how we can tell these apart. Otherwise, just about everything's exactly the same. Just a few very minor changes. The way this note is written here, the way this note is written here. Nothing else has really changed. So now, which capacitor? So we're looking at the original the original schematic, or the one I've been following all the way along with the incorrect pin number. Which capacitor? Well, you know, we can look at it this way too. There is a signal that's trying to be conveyed through the radio, and that signal is pushed through capacitors at time, and if the capacitor is bad, maybe the signal doesn't come through right. And that would be this one right here, which is kind of isolating away all this antenna stuff from the grid itself. You know, if this capacitor were, well, I don't know about leaky, but if it didn't have any capacitance, it would weaken the signal coming through here. It's playing into a very high impedance circuit, so this would have to be a really bad capacitor to not work well. But that's a possibility. These bypass ones, I don't think they're quite so critical for now. That's a big one down here. C1000. Okay. So this one is conveying the oscillator signal. Is it really? Is it? I'm not sure what it's doing. I'm not sure what that one's doing. Let's go on for some more here. So this is the one I changed, the blocking one that's blocking the B plus over here from getting on the grid, this tube. So this one is conveying all the audio through it, and it's playing into a, look at the size of that resistor, a very high impedance circuit. It means you don't really need much capacitance here to make this work. If it's leaky though, this would be a bit of a problem, because there is DC sitting here. The AVC voltage is developed right in here through this diode. So there's some DC here. So if this was really leaky, some DC would affect the potential of this grid. And this grid is biased. It looks like it's self-biasing. Is that right? Or is it doing something with the cathode? No, nothing done with the cathode. So, you know, if this was really bad, I think it would weaken the radio really bad. You'd have, I don't know how you could have DC flowing through here. You got a 10 mega ohm resistor, and besides it could flow down here. Oh, can't go anywhere. So the concern here is if you draw some DC through a potentiometer like this, then the potentiometer can be noisy no matter what you do. Every time you change the volume setting, because a little bit of DC can sort of have that effect on it. Also, you'd be draining down the DC available for the AVC system if this were really bad. Still, that's a huge resistor there. Maybe not. This one's more affecting the tone of the radio. I don't think it's critical at all. This one is, what is this guy doing? So it's between the plate and this, so it's going to ground, going to B minus from B plus at the plate. I don't know exactly what this is doing. Probably C27 is probably trying to get rid of any RF that still exists this far into the circuit. I'm not exactly sure. And if this one were a little leaky, I don't think it would do anything. I think also that's probably a ceramic. Oh, C. Yeah, that is ceramic. Ceramic. Tubular. Okay. So we don't have to worry about that. Already did that one. So this one, I think is doing kind of the same thing. I could be wrong. It's trying to get rid of any RF that might still exist here at this point in the circuit. But I could easily be wrong about that. Then, you know, is it critical? It's on a low impedance circuit now. If it's a little leaky, I can't imagine this one would cause a big problem. We're talking about minor leaks through capacitors here. We're not talking about significant currents. So what do we get out of all that? We got a bunch of audio. We got an audio one here, and we've got an RF one back yonder here. This one, C. So this is a ceramic. So I don't think we will worry about this one. Really, it's just if they're tubular. So now I got to go through it again quickly and see where there's a T on these significant. Oh, yeah. So these are. So this is a bypass on this. Wait a minute. Yeah, and this is supplying arranging the bias for this tube. We should just check the bias on this tube. I should check the bias on all of them. So that's an interesting idea. I only did it on the output tube. Okay, what to do? Some biases, a couple capacitors, hikes. Nothing's really leaping out here. Why don't we measure the grid potentials on these tubes, which is not easy to do. It's not easy at all to do. Like as soon as you put your meter on this grid, you'll change the voltage of it. 1 megohm. 1 megohm. 2 megohms. Well, I could still try it for fun. Well, another thing I could do is the this side, that side capacitor voltage test. Many capacitors have 0 voltage on one side because they're connected to B minus, and something on the other side. So on one side they got a 0 to B minus. So one of the things you can do is clip your meter to B minus, like the common lead to B minus, and then check the voltage on both sides of these capacitors. Now you should get a 0 on one side. Not necessarily. So if you see a 0 on one side and voltage on the other, you can move on. If you see voltage on both sides, then it's time to stop and think. How's this happening exactly? You shouldn't have voltage on both sides. That's a crazy explanation, because if the capacitor is connected to B minus and you're reading from B minus, of course you're going to get a 0 on one side. That's right, but if you get a voltage on both sides, that one is worth looking at. I'm not saying there's a problem with it, it's just worth looking at. I think it's still a crazy explanation. I think that was a crazy statement. Let's go play around with the radio here. Now, this is a stream of consciousness thing happening here, and sometimes I'm more or less conscious. But I continue streaming, so just be cautious of the things that come out of my mouth. Sometimes they're half-baked thoughts I'm working on. I certainly don't have a script here that I'm following. That should be pretty darn obvious by now. Okay, let's try, just because it's easy to do, let's try voltage on either side of capacitors and just see what that shows up. I'm reconnecting this chassis capacitor, so we have the radio in normal operating mode. Hasn't been on for a long time, 5 days. But I have been doing radio work. I've been working on the cabinet for another radio, which I finished. I put the radio back together last night. It looks fantastic, and I'm going to have it on camera maybe after I get this one finished. But it came out really nice. And now I'm thinking about the cabinet for this radio, which is not in very good shape either. There we go. Okay, so the objective here is to take comparative voltage readings either side. Let's see if I can just get my meter to show up. There it is. Okay, a little out of focus, but I think it'll do anyway. So we're on the 150 volt scale. The meter's going to be connected to B minus. Okay. And we're just going to go on one side of a capacitor and the other side and watch what kind of voltage shows up. We'll start with, let's start with the one that drains the capacitor. I don't think there should be anything here. So this would be the side with something on it. Nothing showing up. Let me just make the meter a little more sensitive. This particular, there's a tiny amount there. And of course, I'm just making sure. Now, actually, I'm reading through the chassis, aren't I? When I do that. Okay, this is not going to be interesting until I hit one. So we'll try this one. Okay, one side, it's the same as the other capacitor. No movement. And the other side, no movement. A little tiny movement. This one here. So this has the ABC voltage on it. You can see the meter going negative there. Other side. And I'm looking really closely at this one. Make our meter more sensitive. There's no sign of any voltage on the other side of it. Okay, we'll try this guy. So this is one side, nothing. The other side, a little bit there. A negative voltage there. Negative voltage there. I wonder what capacitor. That's a big one too. Another way of doing this is change the big ones. Well, that's another way of going at this. That's a fair size one. It's got damage on the wax right here. We'll figure out what that one is in a moment. Here, nothing on one side. Sometimes there's wax on these wires, you know. Nothing on the other side. Okay. Skip this one. This one has to do with the phono input. Okay, so down here's the audio capacitor. So there's a little negative there. And on the other side, nothing shows up. Okay, there's one more down here. Oh, it's right on the on the B minus. So I'm just going to go on this side here. So the meter's behaving a little bit weird there, jumping up and down, but generally going down. That's another showing a negative voltage there. That's interesting. What's this one doing? The last one is this one. So big voltage on one side. That's on the 50 volt scale, went right over. And on the other side, not sure I'm getting it here. Oh, the other side's way under here. So there's a positive voltage on this side. Other side. Oh, okay, so here's an example of one that could be in trouble. We have a fairly large positive voltage on one side and then a small positive voltage on the other side. So that's, if I remember right, which ones was it? Certainly this one. Let's figure out what this one is. This one's got me worried. Hey, there's another one hidden under there. Okay, so the other one, I think it's the same as this. No voltage, and coming up the other terminal. Hear it. A negative voltage, tiny negative voltage. Why would there be a tiny negative voltage somewhere in a radio? So, oh, okay, it's because I'm on too high a scale. 5. Okay, that could just be the ABC voltage there. No, I don't think so. So here's another one that doesn't seem... it doesn't seem right. So let's just sort it. Okay, we'll do this one. This guy is connected to... He's on the output tube. And he's connected to... Oh my gosh. Let's turn this off. At this point, I'm going to get my fingers right in there, I think. So this is pin 7 on one side, and you know what? It's pin 1 on the other. Really? 1 and 7. Across pins 1 and 7 on... Oh, 1 and 7. 1. Well, let's take a look at the schematic here. 1 and 7 on the output tube. What are you doing? So 1 and 7 on the output tube. This is the old schematic with the wrong number here. This is 7. 1 and 7 is that. So now what did I read on? I read on it. So here we have a cathode resistor, which is going to push the cathode a little bit positive relative to B minus. The cathode's a little bit positive, so I'm reading big positive and a little positive. That's exactly what was on that capacitor, so no problem. What I found is not a leak. It's just the operating position of this capacitor because of this resistor. That also gives me a hint on biasing again. So if I subtracted those numbers, I would get the bias amount. Okay, I'm not going to worry about it. Let's go back and try another one here. Let's try another one. There was the one up here that I found. I cannot remember which one it was. Shame on me. Too many things at once. Okay. Yeah. So we have the ABC voltage showing up. Oop, on the screw on the capacitor frame, which you can't see because of my arm. A little negative voltage showed up there. The other side of this capacitor. That's okay. And then maybe it was this one. One side, big negative. Other side goes to here. So I wanted to check what this one was. The big capacitor, cracked in it, a negative voltage on it. Does that voltage change when I tune the radio? See a little voltage there? Yep, it does. Okay, so we're seeing ABC. So we want to figure out which one's this. Which one is that? And it's hooked up to, I think, the primary side, I can't be sure, of this IF transformer. So this is IF number 1. First IF transformer. The capacitor goes from, I would say, it's probably the secondary side. Secondary side. To this point is a B minus. So this is going to B minus from the first Okay, let's look for it. First transformer, something going to B minus. Here we go. First transformer, capacitor, somewhere. Huh, I don't see anything. And we had these transformers wrong. This one. Here's one. Oh, that's a C though, not a tubular. It's a huh. I don't see anything. Oh, I'm missing something here. Okay, I'm just going to look back at the radio myself and double check the so there's the same pin the capacitor goes to on the IF terminal has a resistor 22 that looks like a blue color, could be green, 22 something, and there's also another resistor, there's two resistors on it, brown, black, green, looks like a 10 meg. 10, looks like a 10 mega ohm resistor. A 10 mega ohm resistor sitting here. So maybe this is the one I found. No, it can't be. And it can be very tricky because physically the capacitor can be in one place, but electrically it's in somewhere actually kind of remote from where it's sitting. Okay, so if I do it this way, let's see, the 10 meg goes to doesn't go to B minus like it shows here. Yeah. Okay, bear with me here just a bit longer. So it goes to a place where there's two resistors coming from it. One resistor is going straight from one, the 22 green or blue is going to the other IF. So there's a resistor running between IF terminals. There's a resistor, there it is right there, 2.2. It's hard to find, right? Look how it's done in the schematic. Round, up. So that's the 22, and this must be the capacitor. This must be, and then there's another resistor. Here it is here, 1 meg. Well, I was saying 10. Saying 10 when I should be saying 1. 1 meg. So that's them. That's it. That's the guy. Now, what's it doing? So it's coming up. This is an extension of the B minus coming up here. So it's a fairly large one, and it's pulling. It's on the ABC line in between these two large resistors. Well, I guess if this is leaky, it would definitely a small leak in this capacitor would drain pressure out of this part of the circuit because it's so high impedance. It's got this 2.2 mega ohm on one side and 1 mega ohm and then open grids on the other. So a tiny leak here would affect the ABC. A leak of what? A leak of what? Well, a leak off the ABC. So the ABC is being drained out here potentially. Yeah, okay, let's go after that one. Check it out. Now, to make this a little more, I hate to say scientific, make it a little more interesting, I should have the radio in a stable operating condition, measure the ABC voltage, change the capacitor, and then measure it again. And see in a stable operating condition. So where to measure? So I should measure the ABC right on this capacitor, right after the 2.2, right in that zone there. Now I'm using a fairly high impedance meter to do it, 10 mega ohm meter, but considering, the meter itself may do the same as the capacitor and drag down a small amount of charge, drag out leak out a small amount of charge and depress the pressure in that part of the circuit. Let the pressure out, like pushing the valve on your car tire. Only the tire goes flat almost instantly, so it's hard to see on the meter that you've let the air out. Okay, that's enough thinking about it. Let's do it. Let's do it. Okay, hurry, Jim. A beautiful sunny day is going by outside. So we want to measure the AVC on the active end of this. So one of the things I do when I'm touching a sensitive circuit, I'm listening to what comes out of the speaker. I'm looking for a change in the operation of the radio. It's going to change a certain amount. Clicks, pops, added hisses, everything. What happens when I touch that part? I hear no change in the operation of the radio. And I'm looking over at my AVC voltage here. And I'm going to clip on this my meter. Okay. I want to clip it basically onto this resistor. Up out of the way so I can do the work on the capacitor. So there we have a reading. I'm not going to write it down because where? Because I should have a little bit of tape here handy. That's why. As it turns out, I don't. Come on. Okay, a little bit of tape. I'm going to mark the meter. Now, what about tuning the radio? How quite sensitive, but here's a good chunk of noise here. Right up at the top. There we are. Now, let me see if I can line up with the camera here. A little hard to see, isn't it? There we are. That's the spot. Don't have to remember a number now. Power off. Nip out the capacitor and test it. Jumped right at one as soon as I got a chance. Oh, it's in bad shape there. Cracks. This is funny. It looks almost like something liquid has run onto it, but I don't know what that would be. Okay, let's give them the go. Did we pick the troublemaker? That's basically the question. Oh, wait a minute. I'm the troublemaker here. Just in case you've never watched this being done, this guy's going to put a little voltage on the capacitor and indicate if there's any current leaking through it. There should be no current measured. The measurement shows up on the magic eye here, which you can't see. Let's try that. It's a little bit better. So down here is an open part of the magic eye. Okay, and so when I throw this switch, the capacitor will get 50 volts put on it. Never mind, it says 25. It'll get 50 volts. The eye should pop closed and pop open again. If it's a good capacitor, it'll be open like that in a fraction of a second. It's a piece of junk. So at 50 volts, this is a very, very leaky capacitor. So this is the second one I've done in this radio. That's 2 for 2, 2 duds for 2. So this is beginning to tell me that all the capacitors are probably shot. Surprise! No, not really. Not really. The surprise is when they're good, which doesn't happen all that often. Okay, so he's out. I gotta put another guy in there. How big was this one? Is this a 0.1? I don't know if I can read it through the wax here. I cannot read it. So on the schematic, I'm just going to take a peek myself here. Just hang on a moment. That capacitor was a 0.05. Okay, so I'm going to fit a 0.05 in there, and we'll see what happens. Okay, that's the capacitor installed. Okay, meter's still ready. We just have to turn the power on. Let's see what we see over here. Here we go. Okay, first power on, dim bulbs, no problem. What's the meter gonna do? It's going to do anything. It's coming up. It's coming up. Come on, keep going. Oh. Okay. So I'll tune the radio a little bit, and maybe something funny happened with the tuning of it. Unexpected result, for sure. I expected more negative voltage here. Okay, tuning. No, that's the new that's the new level. Oh, okay. Well, this is the stuff I just love. When things don't add up, it means there's room for me to learn something here. Let's just try this radio out now. Let's see what we get. If anything. Should have stations right up in this area. Now the antenna may not be aimed correctly. Nobody home. Oh, soldering iron here. Soldering iron. There's a station there. Huh. I wonder. Okay, so I wonder, that's where I'm going to leave that, so I have something to wonder about today. Why the voltage would be less negative after supposedly removing a leaky capacitor. That raises all kinds of questions. Since the ABC voltage is the rectification of what's coming out of the IF, if what I did detuned the IF somehow, then the output would be dropped, and then the rectified output would be lower, and then the ABC would be lower. So maybe this affected the tuning of the IF in the radio. But I'm going to save all that for tomorrow. I got more capacitors to go after. This is going to mess up the dynamics in the radio, obviously, and result in the requirement for another alignment anyway. But for sure, 2 capacitors out, both leaking significantly. So I think the rest are probably going to have to come out. Thanks a lot for watching. I hope you enjoy your day like I'm going to enjoy mine. I'm going out to play with my cats now. See ya.